This is a video of the Accuracy, Precision, and Density Lab. First, you have an electronic scale, you have a graduated cylinder, you have a beaker of an unknown liquid, you have a metal bar, an irregular shaped metal object in a dish. For part 1, we're going to test the density of an unknown liquid. We're going to measure the mass of our graduated cylinder. We have changed it from 25 to 50 by using our electronic scale. Turn on your electronic scale. Once it's on, ensure that it's in grams. Set your graduated cylinder on the scale, and then click tare. Once you click tare, it should zero out. Take your graduated cylinder off the scale. We're going to add 10 milliliters of liquid into our, going as carefully as we can. Okay, reading from the bottom of the meniscus, get at eye level. When you do, then you're going to go ahead and set it back on the scale. The mass of the graduated cylinder that now contains the liquid is 6.84 grams. Okay, please record that on your data table. We'll put the unknown liquid back in the beaker. We'll repeat this steps for trial 1, 2, and 3. Okay, trial 2. If you pour using a funnel, pour it up to about 8, and then you can use the pipette to help you with a bit more accuracy. Oh man, and a little over, friends. All right, and weighing it, our answer is now 6.61. Trial 2, 6.61 grams. Okay, trial 3. There we go. 6.33 grams. Trial 3, 6.33 grams.
Okay guys, so we're now going to do part 2, and this is going to show the density of an irregular shaped solid. All right, so this is going to be our irregular shaped object or solid, and so the first thing we need to do is we need to get the weight of this guy. All right, and so I'm going to go ahead and turn on my scale. Again, it's in grams. We want to make sure that is grams, and that's our basic unit for weight. Okay, and then I'm just going to go ahead and put that on there and let it go, and I got 43.79 grams. All right, on that. All right, that was the first time that it stopped. Right, so 43.79 grams. Okay, is the weight of this object for you. Okay, I'm gonna go ahead and take that off. All right, and now what we need to do is we're gonna use the graduated cylinder again, and what we're gonna do is we're gonna fill that guy with 10 milliliters of water. And you can write that on your table for trial 1. The volume of the liquid, well, we put 10 milliliters of water, okay, for that guy. And so I'm gonna go ahead and do that. I'm gonna use the water bottle, probably the best way to do this, so I'm not spilling all over the place. I'm gonna do my best to get it on that line, or at least under that line. Almost. One more squirt. I'm gonna give it one more squirt. There we go. Awesome. All right, so now we have that 10 milliliters of water, okay? And what we're gonna do is we're going to see if the milliliters will change or how much it changes when I put the irregular object in the cylinder. Now this may get a little messy, so what I'm gonna do is a little bit of a method. I'm gonna kind of lean my guy, and I'm gonna let it kind of slide in the best I can, as slow as possible, and then kind of lean it as it goes, and that way I don't get so much splash. All right, a little technique there, okay? And at that point, we wanna see exactly how much it moved from 10 milliliters. So I'm gonna show you this the best I can, up close. Turn it just a little, there we go, okay? And you need to figure that out, right? And if you did the pre-lab, you know how to read this meniscus, right? And you should be able to get that number. And we're gonna do this 2 more times. Okay, guys, so for trials 2 and 3, understand you can do what you can do is you can just copy the mass of the solid across, right? And I believe we got 43.79 grams. So you're gonna put that for trial 2, and you're gonna put that for trial 3. Same thing for your volume of water. We're always gonna use 10 milliliters of water, okay? And what we're looking to do is to test when we put it in, does anything change, or are we getting the same precise number? Right, so that's the part I'm gonna do and show you for trials 2 and 3. All right, so again, across, put your 43.79 grams for the solid, mass of the solid, and put 10 milliliters for the volume of the water, because that's what you started with, okay? All right, so here we go again, okay? I've got my 10 milliliters of water, and I'm gonna take my irregular object. I'm gonna kind of use my technique again, kind of lean that to the side here. I'm just gonna let that guy slide the best I can, so I don't get too much splash. There we go. All right, and then here we go. For trial 2, you can see what you got. I'll turn it a little bit. Again, if you did the pre-lab, you know how to read this meniscus, and you should be able to get that number. Awesome. All right, and so I'm gonna do this one more time, and you can kind of see what I'm doing here. Is I'm just gonna empty that out the best I can. All right, to make sure I get as much of an accuracy, I'm gonna dry this off a little bit. Okay, and I'm also going to try and get a little bit of this water out of my cylinder, just a little bit there. You don't got to do too much here. Don't get crazy because you might crack the cylinder, okay? All right, and I'm going to do this again. So I'm going to put that 10 milliliters of water. Remember, we're going to keep doing the same mass and the same amount of water that we're going to start with. We're just looking for the drop. Okay, let me turn it around so you can see that, sorry. I'm going to put 10 more milliliters of water in here. All right, need maybe a tad bit more there. Good. All right, so I have 10 milliliters of water again. I've got my irregular object that's now dry again, and I'm going to do the same thing. Take my little lean so that I don't get too much splash, and drop that sucker in there. Good. Okay, and there you go. I'm going to show you exactly what you got for trial 3. This is the one that may be a little different, and you'll need to record. Okay. All right, and again, if you know how to read this, you will know how to read that number.
Okay, part 3, the density of a regular shaped solid. Okay, first we're going to put our solid onto our scale. Again, making sure that it's clear. We are still in grams. I'm going to set that on there. Let that come to calibration. Our answer here for the mass of the solid is 33.53 grams. 33.53 grams. You may use that same mass for trial 1, 2, and 3. Okay, now we're going to go ahead and measure the length, width, and height using centimeters. So here we have our ruler. We have inches and we have centimeters. Please make sure you're using the correct side, otherwise it will not get you the right answers. The length, we're going to go with this longest part here. Now when I hold this on here, I'm going to put it real close to the camera so hopefully you can see. Here we have 1, 2, 3, 4, 5, 6, 7, 8. Oh, not fully 8. So take a real close look at that. And please record that number. This is the length in centimeters. Okay? The width, we're going to go across this way. So I'm going to hold it again real close for you. We have 1, 2, 3, not quite 3. Check it out, be very specific. I would like a decimal point, please. I would like a decimal point, please. That's going to be the width of your solid. The height gets real sneaky here. Okay? The height is when we're sitting up like this. So we're going to go, here we go. Really small here, be very accurate, friends. Not even 1. We are looking for a decimal. All right, please record that. Now, what you're going to do is you'll see a note. To get the final volume, you're going to multiply the length times the width times the height, and that will give you the volume of your object in centimeters cubed. Centimeters cubed. Okay? I'm going to go ahead and show you two more times just in case for your length. All right. For your width, double check your measurements, and for your height. Okay, all right, record that for trial 2, and one more time for 3. Okay, length, now width. There you go, friends. And height, one more. Last one, y'all. I'm hoping your measurements are accurate and precise. Thank you so much. Now you may calculate the density by using the mass and the volume. Remember, density is equal to mass divided by volume. Go ahead, finish up your data table.